Hi, everyone. In this video, we're going to be talking about compound interest. So for simple interest, we have an investment or a bank account. You have an investment or loan that accumulates interest at a constant rate each year. And this constant rate, at a constant rate each year. And what this means is, so this means the same amount is added in interest each year. And this is a percentage of the principal. Compound interest grows faster. Instead of growing at a constant rate, we take a percentage of the current balance. And so this is sort of interest on interest. And so before I define what's going on, let's look at an example of how this would work. So suppose you put $100 into an account with 10% annual interest. And suppose we compound annual. What does this mean? This means after year 0, the balance is $100. After year 1, the balance is $100 plus our interest which is 10% of $100. So this is 100 plus 10, which is $110. So between year 0 and year 1, we get $10. This is exactly the same for this first year as if we did simple interest. But for year 2, our balance is $110. So our balance from the previous year plus 10%, not of $100, but 10% of $110. So for simple interest, if this were simple interest, we'd be doing 10% of 100 every year. Every single year, we're adding the same amount, 10% of $100. But for compound interest, we're taking the percentage of the current balance, not the principal. So this is 110 plus 11, which is 121. And then year 3, our balance is 121 plus 10% of 121, which is 121 plus 12.1. So that's 133.1, etc. And so we're taking interest of our balance plus our interest. So we're taking interest on interest. And that's what we mean by compound interest. And so compound interest, we can also compound more than once per year. And so in this example, we could, instead of doing the interest calculation, once per year at 10%, we could do it twice per year at half of 10%. So at half the interest rate. So that would be twice per year every 6 months. And there are various compounding periods that different accounts or loans offer. So you could compound once a month, you could compound once a day, once every 3 months, once every 6 months, once every year. These are the most common. And so our formula for the future value for simple interest or for compound interest, future value is equal to the principal times 1 plus, now this is where it gets a little complicated, R over N to the power of N times T, where F is the future value, P is the principal, R is interest rate, the annual interest rate as a decimal. T is the term or the amount of time. And N is the number of compounding periods per year. Okay. And so how we can break this down by number of compounding periods is if N equals, so we can compound annually. This means once per year. And so this corresponds to N equals 1. We could compound semi-annually. This would be twice per year. This corresponds to N equals 2. We could compound quarterly. That's once each quarter. Well, we have 4 quarters per year. That's once every 3 months. So that's 4 times per year. That's N equals 4. We could compound monthly. That's 12 times per year. That's N equals 12. Or we could compound daily, which is 365 times per year, once each day. And that's N equals 365. And again, we're going to be using 365 for a year. We're not going to worry about leap years or things like that. And so there are other compounding periods that are possible, but these are the main ones that we'll be using. And so before we do some examples of this, I just want to mention that bank accounts, so bank accounts like savings accounts, are a type of investment. You're giving a bank money, and they can use it. They can use that money. They have to hold a certain amount of it on hand, but they can use that money and they pay interest for the privilege of using your money. Essentially, you are loaning the bank money but there's no fixed term length. You can keep it there as long as you want. So you can keep your money in the account for as long as you want. Okay, and so let's do an example looking at a bank account. So typically, and again, this depends on the precise account or loan, but often bank savings accounts and loans will use compound interest. So an example, you put $3,000 into a savings account which bears 3.8% annual interest. Annual interest is also called APR, which is annual percentage rate. And this is the same thing as the interest rate. So if you've seen something like a car commercial where it says 0% APR for the first 12 months, that just means they don't charge you interest for the first 12 months of your loan. So 3.8% annual percentage interest, so annual interest, compounded monthly. And so the question is, what is the balance of the account? How much is in the account? So what is the balance after 5 years? Okay, so we use our equation. We want the future value. How much will be in the account in the future? F equals P times 1 plus R over N to the N times T. So our principal, this is the amount we initially invest. That's $3,000. The other way of looking at it is the bank is taking out a loan from us for $3,000. So 3,000. R is the interest rate. So that's 3.8% as a decimal, which is 0.038. And this is the number of compounding periods. We see we're compounding monthly. So if we're compounding monthly, how many? So the question is, how many times, how many compounding periods per year? So N is 12 because we're compounding once per month. There are 12 months in a year, so that's 12. And then T is in years, that's 5 years. So now our first step for these types of questions is to do this calculation here, N times T. So that's 12 times 5, which is 60. And so now I work from the inside out. I'm going to do this R over N first. And so that's going to be 0.038 over 12. And then when I put this into my calculator, I'm going to round to 9 decimal places. So that's going to be 0.003166667. So here, it's really important to round to 9 decimal places. partially because this is a very small number. If we just rounded to 2 decimal places, we would see this 0. We'd see the next one's a 3. And so we would round down and we would just round it to 0. But this is very much not a 0 number, and that will change our answer quite a bit. So now we do 1 plus r over n is 1.003166667. And then we do 1 plus r over n to the n times t. So that's our 1 plus r over n, which is 1.003166667 to the n times t power. So that's to the 60th power because n times t is 60. And this is where it's important that your calculator can do exponents besides 2 and 3. So I'm going to do 1.003166667. I'm going to raise it to the power of 60. So that's 1.2, 1.208, 886, 660. Rounding it to 9 decimal places. Finally, to get our future value, we multiply this number by p. So p times 1 plus r over n to the n times t. So that's our $3,000 times 1.208886660. And then, so when I put this into my calculator, I'm going to get, and I'm rounding it here to 2 decimal places because this is my final answer. I'm putting this into dollars and cents. So this is $3,626.66. And that's my final answer. So what this tells me is that after 5 years, there will be $3,626.66 in the account. Okay. And one last thing I want to mention, we've been mostly focusing on loans. So we've been focusing on computing balances for loans rather than for bank accounts, for bank/savings accounts. Okay, but the math and the variables are identical. It's just a matter of what perspective we're looking at. And another thing is, you might be wondering, how do I know which n to use? Right? How do I know whether I'm compounding? What should I be compounding 6 times per year, 10 times per year, whatever? Well, it will tell you in the question. It will tell you. It will say compounded annually, compounded monthly, things like that. And then it's up to you. It's your job to say compounding monthly. That means we're compounding 12 times per year. Compounding quarterly, we're compounding 4 times per year, etc. And this isn't something that's something you have to figure out, right? Well, you have to figure out from the statement, but you're not going to be saying, you don't have to figure out, oh, it's monthly. Different banks and different accounts will have different compounding periods. Okay, so we'll see more examples in the next video, but that's all for today.